Dajahan. Okay, welcome. I'm Ben, and let's continue from where I stopped in electrochemistry. Dear students, those who are going to do their KCC exams, Kenya 2023. Today I want to finish a bit part of electrochemistry. But if you have any question, my friend, you are free to ask. And I recommend you to go to Made Familiar Chemistry and tackle every question concerning electrochemistry. Now, if you go to your Made Familiar, there's a question 2006, question 15.1. Study the standard reduction potential given and answer the questions that follow. Study the standard reduction potential given and answer the questions that follow. The letters are not the actual symbols of the elements. Now you have been given M aqueous, so M2 plus aqueous plus 2 electrons. E value or the volts is negative 0.76. N2 plus aqueous, that is N aqueous plus 2 electrons to N solid. E value is negative 2.37. We have P plus or P aqueous plus an electron plus E to P solid. E value is positive 0.80. Q aqueous, so Q to plus 2 electrons to give you Q solid is negative 0.14 as the voltage. The first question is the standard reduction potential for ion. Ion, remember ion is Fe. Fe 2 plus ions is negative 0.44 volts. Select the element which will best protect iron from rusting. 1 mark. Now they want you to select element from the table. We have elements here M, N, P and Q. They want you to select those ones, any that can protect iron as element from rusting. Now, for us to select this element, we must look at the E value, and that E value which is more negative will possibly actually protect iron from rusting. That element with the most negative E value, I told you to go and write this area, because the more negative E value, that's the most reactive element and is the most reducing agent. So if you look at M, negative 0.176, N, negative 2.37, actually N is having more negative E value of negative 2.37. So that is the most reactive element, and hence N can protect iron from rusting. N having the more negative E value will protect iron from rusting, because iron has even less negative E value. So when these questions are set, you look at the more negative in there that can protect something from maybe an iron or whatever from rusting. And that's how they are always applied in making the sulfuriants, the cooking pans and whatever. So N is the answer to part A, can protect iron from rusting. Now, part B, calculate the E value for the cell represented by or represented as M solid, then phase boundary, M aqueous, so M2 plus aqueous, then salt bridge, you remember, P plus aqueous, then phase boundary P solid. They want you to calculate the E value for M solid, M aqueous, P aqueous, P solid. Meaning that is the electrochemical equation of M and now P. From the table we had M and P also is there, and we have N of course with Q. So they want you to calculate the E value, electromotive force, the E value of M and P. Now let's go to M. M is negative 0.76. P is positive 0.80. Now dear friends, for you to calculate this one, the E value, then you must go back and look at this short narrative. E R minus E O. What do I mean? E reduction minus E oxidation. You are going to take that, the volts of the element that is being reduced minus that which is being oxidized. And remember, reduction is the gaining of electron. R, gaining electron. That element which is gaining electron, that's the reduction process. And oxidation is that which is losing to that of that which is gaining. Now when you look at from our table, M is negative 0.76 and P is positive 0.80. In that scenario, M is having negative and P is positive, to mean that M is the most reactive here, having the negative. I told you then the most reactive will be on the left hand side of the electrochemical cell, and the positive will be on right hand side. So because negative is losing electron, the negative is losing electron, the positive is accepting electron. So M is one which is now losing electron, giving to P. So M is the most reactive. If being the most reactive, it is one which is now losing electron, it is now oxidized. Get it clear? It's being oxidized. It's going the process of oxidation. Remember, oxidation is the losing electron. When M is losing electron, it is being oxidized. So M is going the process of oxidation. But P is being P is getting electron, and maybe gaining electron is the reduction process. Remember, P is gaining electron. Gaining electron is the reduction process. So P will gain electron. And what's the formula? E reduction minus E oxidation. And which one is being reduced? P, because it is gaining electron. Reduction is the gaining electron. So P is gaining. So you will take, we have the formula here. E value is E reduction minus E oxidation. ER minus EO. So positive 0.80, that's for P. Remember, P is gaining electron, and gaining is reduction process. That's why ER minus, in bracket, minus 0.76, that is for M, which is losing electron, and losing electron is oxidation process. And respect the brackets, respect this area. When you do this calculation, you get positive 1.56 volts. You must put the, and positive, it is positive. You must put the sign. Then the sign, the unit, volts, V or volts. So you get that one, student, ER minus EO. And get what's the meaning of reduction and meaning of oxidation. Thank you. That is 2006, paper 1, question 15. Go and look at it. Part B. Then 2007 question, there's a question here that you can get. 2007. Yes, yes, this 2007, question 7, paper 1. Use the information given below to draw a label diagram of an electrochemical cell that can be constructed to measure the electromotive force between G and J. 2007, question 7, paper 1, made familiar. Use the information given below to draw a label diagram of an electrochemical cell that can be constructed to measure the electromotive force between G and J. G 2 plus aqueous plus 2 electrons to G solid, you have been given E value to be negative 0.74 volts. Then J 2 plus aqueous plus 2 electrons to give you J solid, E value negative 1.4 volts. Now J and G is having negative 0.74 volts, J is having negative 0.14 volts. Now G is having the more negative because all of them are having the negative values. G is more negative E value, electromotive force, which is 0.74 negative. J is negative 0.14. In that case, they want you to draw an electrochemical cell. Look at the E value. G is having more negative. Where will it be? On the left hand side of the electrochemical cell. And J will be on the right hand side of the electrochemical cell, because it has less negative E value. 2007, question 7, paper 1. So how do you draw it? What I told you last time, you draw electrochemical cell, put this one, the can for the G. So G, because it has more negative, it will be on the left hand side. So G rod, this is the G rod. Then here, put G2 plus aqueous, is solution of G plus here. This side is J rod because it was less negative, and J2 plus aqueous is in solution. Then we have the salt bridge is here. Before the salt bridge, these are the metallic wire is here. This one is the voltmeter, this metallic wire. Then you put the salt bridge having potassium nitrate or sodium nitrate, and there you have your 2 marks, because J having more negative will be on the left hand side, G and J will be on the right hand side having the less negative E value. So that one is very important to note. Then question B of that number, calculate the E value of the cell constructed. So E value of the cell, I will write it. Remember that for J is negative 0.7, for G is negative 0.74 and J is negative 0.14. So G is having more negative 0.74, but J is having less negative. So which one will be? First thing, write the formula. ER minus EO. E reduction minus E oxidation. So you ask yourself, which one is being reduced? That is being reduced. Reduction is the gaining electron. So you go to the element which is gaining electron. That one which is on the right hand side, J, gaining electron. That is R. So you take E value of negative 0.14. Negative 0.14. That's for J. It's gaining electron. Gaining is reduction. ER minus E. Minus, in bracket, minus. That is of the, now J is losing electron, and losing electron is oxidation. That one EO. So you take negative 0.14 minus, in bracket, minus 0.74. You get positive. So actually it should be positive. Put there positive 0.6 volts or V. That's how you calculate E value. Make sure you know the E reduction, E oxidation, and you must make sure that you know which one is being reduced, which one is being oxidized. You can calculate it. Simple. It's okay. Then maybe lastly, so maybe last, we have this. Okay, these questions will be coming, and you must be in position to answer this also. So we have this question in page number 2017. So we have 2017. In 2017, paper 2, question 2B. 2017, paper 2, question 2B, made familiar. That kind of a question where you have been asked about, you calculate the, remember the Faraday. The Faraday. You go and read the area of the Faraday. And Faraday is an area that is always also asked, and you must know. So I want you to go to Made Familiar, look at 2017 question, paper 2, question 2B. 2017, paper 2, question 2B. You are going to get a question there about the Faraday. How to calculate the mass, and it was for copper, things so. So they asked, calculate the mass of the copper that's remained. You have been given there current, you have been given there time, and you have been given Faraday. 1 Faraday is equal to 96,500 coulombs. Remember that area. So if this question is asked, the first thing you do, my friends, calculate the quantity of electricity passed. QEP, quantity of electricity passed. How do you calculate? I times T. I is current times time. That one I'm talking about 2017 paper 2 question 2B, made familiar. So time we are given there to be 0.6. Ampere current is 0.6. That's I 0.6. So it can be I or amperes, the amperes, that's the current. Times time will be given, you are given time there, 11 over something, I think you will find it. The first thing you do, take time, change time into seconds. That's the first thing. Remember time you are given there in hours. When given in hours, make sure you change everything to seconds. When given into minutes, make sure you change everything into seconds. So the time you are given there, change it into hours by multiplying by 60 to change into so 60, then another 60 because we are given 2 hours. Change into 60 to change into minute, times 60 again to change into seconds. Simple. When given into hours, multiply that one by 60 to change into minutes first, then by another 60 to change into seconds. But when given into minutes, then just change times 60 once, then change into seconds. Simple. After changing that time into seconds, multiply that time in seconds by the A amperes or the current you have been given. You have been given there 0.6. So if you multiply, you are going to get 3240. See, go to that question, you'll see it. Then that C, remember in that question 2017 paper 2 question 2b, you are given there silver. I think it was silver. The silver as the gram of silver is 108. 108 is like RAM or RMM of silver. Like number, so molarity, the molar mass of silver is 108, molar mass in short, or RM. You have been given there 108 gram. So that 108 gram of silver is equal to the Faraday, constant Faraday umepewa, which is 96,500 coulombs. That one will be given in exam. So the molar mass of that element, be it copper, sometimes it's copper is around 63.5, is equal to that one of Faraday, which is 96,500, or whatever will be given. And remember the fact you calculated the quantity of electricity passed, which you got 3240. See, by multiplying time and what? Current. So you will say, if 108 of silver, or let's say for copper, 63.5 for copper, or something you may pay. In this case, 108 for copper, or for silver is equal to 96,000 for Faraday C, for the Faraday. What about the coulombs you calculated the first step? What about 3240? What will be? Then you do calculation, cross multiply, 3240 times 108 divided by 96, whatever, you're going to get the mass, which is 3.626 gram. My friend, that area is also important for you to know. No shortcut. So you must know it and know it. If you have any question concluding with the Faraday, ask before you do your exams. Make sure you tackle every question you made familiar and every question you meet with in a paper concerning electrochemistry. And as in electrochemistry, first know this one. Know the meanings, know the gaining electron induction potential redox, how it applies. Know how to calculate oxidation numbers. Make sure you read rule number 5 and rule number 6. Rule number 5 and rule number 6 in calculating oxidation numbers. Very important. Then make sure that you know electrolysis and application. Read about Leclanche's the application of electrolysis, the Leclanche's and etc. Those cells. Why is in the paste in the Leclanche cell? Why do we use paste? Why? What? Those questions are there, and you must be able to answer them. Go and read about them and the equations. And my friend, in electrolysis, where water is being also ionized, go and read those areas. They will come in your exams. So such kind of things can come. Know how to calculate the electromotive force, know how to draw electrochemical cell, and then coming up with an equation. If you have a question before the exams, we are free to help you. We are going to proceed with other topics in chemistry, but you have a question, you can answer, and you can ask in electrochemistry, we can answer you. Any topic we'll tackle in chemistry and also biology. Shishi, 13.